why the oceans were salty.
Why the sea is salty.
Why are the oceans salty?
We didn't know why the ocean was salty, how it got its chemistry, until...
If you scooped all the salt from Earth's oceans and spread it across all the land, you'd bury the entire planet under 475 feet of pure salt. That's taller than a 40-story building. Where the salt comes from is one story, and we'll get to that. But the real question is why the oceans don't get saltier and saltier over time. Rivers have been pouring salt into the oceans for billions of years. By now, they should be toxic salt baths, saltier than the Dead Sea. So why aren't they? What invisible system is stopping them from becoming saltier? The answer isn't what you think, and it might be the only thing keeping Earth from turning into a frozen, lifeless rock. In this episode of Natural Forces, we're about to show you why that salty taste on your lips is literally the flavor of volcanoes, ancient acid rain, and billion-year-old seashell graveyards. And by the end of this video, you'll understand how the balanced chemistry of the ocean is the reason our planet is still habitable today. Because this isn't just trivia. The secret of ocean salt is the secret of our climate, our weather patterns, and the very possibility of life itself. Let's travel back 4 billion years to when Earth was basically a volcanic nightmare. Picture our planet as a cosmic barbecue grill gone wrong, constant volcanic eruptions spewing gases and minerals from deep within the planet. These volcanoes weren't just making pretty lava flows, they were literally seasoning the atmosphere with massive amounts of salt ions, including sodium and chloride. This is the moment the atmosphere went full supervillain. When the planet finally cooled enough for water to condense, the first rains weren't gentle spring showers. They were like getting power washed with battery acid for millions of years straight. This acidic rainfall didn't just fill the early ocean basins. It started what scientists call rock weathering, which is a fancy way of saying acid rain slowly dissolving entire mountains. Think of it like this. Imagine raindrops so acidic they could dissolve a penny in your pocket, except instead of pennies, they were dissolving granite cliffs and sending all those minerals on a one-way vacation to the sea. As this acidic water flowed over land, it basically turned into nature's ultimate mineral smoothie, dissolving sodium, chloride, calcium, magnesium, sulfur, and potassium from rocks. This mineral-rich water was carried by rivers to the ocean, and unlike your bathtub, the ocean doesn't have a drain. What flows in, stays in, sometimes for hundreds of millions of years. Here's a mind-bending fact. Some of the salt you taste in today's oceans has been cycling through our planet since before T-Rex was even a twinkle in evolution's eye. We're talking 100 to 200 million years per salt molecule. So here's the million-dollar question that kept scientists awake at night. If salt keeps pouring into the oceans like a broken faucet, why doesn't the ocean keep getting saltier? Modern rainfall still adds salt, but only about 0.000005% to the ocean's total salt content each year. That's like adding a teaspoon of salt to an Olympic swimming pool. But still, over billions of years, that should add up to Dead Sea on steroids levels of saltiness. The answer to how the ocean maintains balanced salinity is actually genius, and it involves what I like to call the ocean's recycling program. First up in our cleanup crew, marine organisms that act like vacuum cleaners for calcium. From microscopic plankton to massive coral reefs, these creatures pull calcium ions out of seawater and combine them with carbonate ions to build their shells and skeletons. The result is calcium carbonate, the same mineral that makes up limestone and chalk. Here's why that matters for ocean salt. Salinity is basically a soup of dissolved ions: sodium, chloride, magnesium, sulfate, potassium, and calcium. Sodium and chloride are hoarders. Once they enter the ocean, they tend to stick around. But calcium is different. Biology constantly pulls it out of circulation. When a coral or plankton dies, its calcium carbonate shell sinks to the seafloor. Over millions of years, these tiny calcium time capsules pile up into thick layers of sediment, permanently locking away what used to be dissolved ocean salt. Coral reefs, in particular, are like giant underwater recycling plants. Instead of releasing minerals, they're burying them, literally mining calcium out of seawater and storing it as stone. That's why calcium makes up only a small fraction of ocean salinity compared to sodium and chloride. If life weren't constantly scrubbing it out, the oceans would be far saltier and chemically unbalanced. Every seashell crunching under your feet on the beach represents one little packet of ocean salt that nature's recycling system has filed away forever. One of the hidden power players of salt regulation, hydrothermal vents, which are basically underwater geysers that weren't discovered until 1977. Picture this: deep ocean water gets sucked down through cracks in the seafloor, gets a spa treatment from superheated magma, undergoes some wild chemistry, and shoots back out like underwater smoke signals. These vents are like the ocean floor breathing, inhaling regular seawater, giving it a complete chemical makeover, and exhaling it with a totally different recipe. They both add and remove different salts, creating an incredibly complex balancing act. Plus, they create ecosystems so bizarre they look like alien planets. Tube worms the size of baseball bats living in conditions that would instantly cook a human. It's like nature's own science fiction movie. Okay, prepare to have your mind completely blown. Salt doesn't just make seawater taste terrible, it's literally running the show when it comes to Earth's climate system. Here's the physics. Salty water is denser than fresh water. That might sound boring, but this density difference drives massive underwater conveyor belts that are basically the central heating system for our entire planet. The Gulf Stream, for example, carries warm, salty water northward, keeping Europe from turning into a popsicle. Without these salt-powered ocean currents, London would have the same climate as northern Canada. Think ice-covered Big Ben and frozen fish and chips. The entire European civilization as we know it probably wouldn't exist. But wait, there's more. Recent research shows that salt is intimately connected to our global weather system. About 77% of all precipitation and 85% of all evaporation happens over the oceans. When seawater evaporates, it's like nature's own desalination plant. Pure water goes up, salt stays behind, making the remaining water saltier. This creates what scientists call the salinity climate feedback loop, which sounds technical but is actually pretty simple. Areas with lots of evaporation get saltier, areas with lots of rain get fresher, and this drives weather patterns across the entire globe. Climate change is turning up the intensity on this system like a planetary volume knob. Studies show this pattern has doubled in intensity since the 1950s. It's like turning up the contrast on a photo. The salty areas get even saltier. The fresh areas get even fresher. In 2022, scientists published research that basically made everyone's jaw drop. They found that increasing ocean salinity from 20 to 50 grams per kilogram results in a 71% reduction in sea ice cover. That's like melting an ice rink the size of North America just by adding a few more tablespoons of salt per bucket of water. This discovery solved one of Earth's greatest mysteries. How did our planet avoid becoming a giant snowball during its early history when the sun was 25% dimmer than today? The answer? Earth's oceans were probably saltier back then, preventing the complete freeze-over that should have killed all life before it even got started. In other words, salt might have accidentally saved every living thing on Earth. Talk about being in the right place at the right time. As strange as it sounds, studying the salt in our oceans may help us understand both the storms of tomorrow and the possibility of alien life. Scientists are now using our understanding of ocean salinity to hunt for life on other worlds. The subsurface oceans of Jupiter's moon Europa and Saturn's moon Enceladus might contain the same salty cocktail that made life possible on Earth, which means that seawater you accidentally swallowed at the beach, it might contain the same recipe for life that exists on alien worlds right now. Ocean salinity has become like a crystal ball for predicting extreme weather. The Aquarius and SMAP satellites are constantly measuring sea surface salinity from space, and unusual salinity spikes can actually predict droughts, floods, and extreme weather events months before they happen. It's like the ocean is constantly sending us text messages about future weather. We just had to learn how to read them. So the next time you taste salt water at the beach, remember, you're experiencing a 4 billion year story that involves volcanic hellscapes, acid rain that could dissolve mountains, tiny sea creatures playing the longest game of hide and seek ever, underwater volcanic spas, and a climate control system so sophisticated it accidentally prevented Earth from becoming a lifeless ice ball. Ocean salinity perfectly demonstrates that everything on Earth is connected in ways that would make even the most complex detective novel look simple. Geology, biology, chemistry, and climate, all dancing together in a 4 billion year performance that somehow created conditions ripe for life. It's not just the flavor of Earth's memory, it's the taste of the most incredible accident in the history of the universe. And yeah, it also happens to go great on fries. Thanks for watching. If you enjoyed this deep dive into Earth's salty secrets, definitely subscribe, because we're exploring all the incredible forces that shape our world. From the tiniest atoms to the largest galaxies, there's always another amazing story waiting to be told.